This is my tutorial on how to make threads in Autodesk 123D Design, like you might find on a bolt in a hardware store. So most of the tutorials I've come across on YouTube build rounded threads using a method that starts with a torus or donut, cuts it in two and distorts the ends on one side away from each other. This method will work great for some applications, but if you're trying to design threads to hold a little bit more tension or for them to be 3D printed like I do, then that method might not be ideal since the rounded shape doesn't hold as much tension and the top and bottom of the radius of each thread is near perpendicular. It starts near perpendicular to the axis of the bolt, which makes it a little bit tricky to print totally clean threads. So the method I'm going to show you uses a 60-degree thread angle, which is the same as unified national coarse threads. It holds adequate load and should produce smooth, clean threads when printed at a layer resolution of 100 microns or finer. Okay. So the way this is going to be done is you're going to produce a thread profile, and then you're going to array it around your minor diameter circle, and then you're going to use the loft tool to basically loft through all these shapes, and then that will produce your thread, which you will just copy and paste and then build into a stack. And then put a cylinder in the middle with the bolt head on top using the hexagon tool. And then the way I clean up my lead in for the threads is I just continue on that 60-degree angle here, and then I just revolve it around, and then that's what leaves me with a nice clean lead in for the threads. So when you start off, you kind of want to approach it with how you're going to do it. So I already know that I want 12 increments in my array. So each of these is 12 here. So 360 degrees divided by 12 sections is 30-degree increments. So each of these is 30 degrees apart from each other. The desired thread pitch is going to be 8.004 millimeters. That's just kind of how it worked out in my math. The profile offset per increment is going to work out to 8.004, my thread pitch, divided by the number of increments in the array is 0.667 millimeters in height offset per thread profile. So this is the thread profile that I came up with. Basically all these numbers are kind of arbitrary, so you can kind of tailor make them to whatever's going to fit your project. So you're going to want to know all these numbers here, and if you're doing outside threads, then you're going to worry about the minor thread diameter, and if you're doing internal threads, then you're going to want to worry about the major thread diameter. So in this case, we're worried about the 50 millimeters here. So start off by drawing a 50 millimeter circle here, which is your minor thread diameter. And then I've already built my thread profile here, and I have made it perpendicular to the circle, as you can see, and it's right at the edge. It starts right at the edge of the 50 millimeter circle. So from here, you highlight your thread profile, you click copy and paste, and then you can see that it gives you your movements that come up here. But the thing is it makes this your rotating point, and that's not going to work for what we're doing here. So you click on the side of the pill, which says Start Reorient. You just click on it, and then that allows you to change the pivot point to the center of the minor thread diameter circle. So you click there, and then you click Stop Reorient. So we're going to go in a counterclockwise direction and turn it 30 degrees. This is counterclockwise for right-hand threads, and it's clockwise for left-handed threads. So now that we've pivoted at 30 degrees, now we raise it up by the 0.667 that I described prior. Now we're going to keep using the one that we've just moved as the copied piece, just because it's easier to keep putting in the 0.667 rather than to try and compound it as you go around. So again, copy, paste, click the side of the pill, move the reorient to the center, pivot at 30 degrees, and then move this one up again by 0.667. So you're going to keep doing that until you have 12, and you're going to end up having 2 of them directly on top of each other like that. Okay, so I finished arraying all my profiles around the circle here. So now we're going to do the loft function. So what you want to do is you'll start off by, you click on the first one, and you need to do them in succession the way that they're going to be lofted. One thing that I've noticed is if the 2 profiles here on top and bottom, if they're touching, for some reason it doesn't like to do the loft function all in one through all 12. You have to do it in groups of 6, and then you just join the 2 pieces together. But since these 2 aren't touching, I can do all 12 at once. I'm not really sure why that is. So you just hold down the shift key while you click on each of the thread profiles that you've arrayed. So just keep holding the shift key through the entire time. Okay, so now I have all of them. So I'll click in the utility thing here, and then I click on the loft function. It looks sort of like a hollow tower. So once you click on that, you can see that it just travels your profile around the circle through all the profiles, like through all the arrayed segments. So once you have that, you just copy and paste, and you move it up that 8.004, that's your thread pitch. And really you just got to do that as many times as you want to make it as tall as you want it to be. I have all my threads stacked on top of each other, and I've merged them all into one model. So the next thing I want to do is produce the actual body of the bolt. So I'm just going to highlight the minor diameter circle that I've already got there. I'm going to go to the extrude function and change that to merge. I'm just going to bring it up 150. That should be good. Okay, so now we do the bolt head. Just click on this, use that as a marker. I'll just do 50. We'll click on that hexagon. We'll extrude it downward. So it's going to go automatically into cut since it's encroaching on the body of the bolt. That's fine. So we'll just change that to merge and return. Okay. So now we have a pretty nice bolt, but it'd be a whole lot more professional looking if it had a nice lead in here, in my opinion. So to make it easier to see the profiles that we're going to be working with in there, we'll move over to here where it says hide solids and meshes. So click that, and then all your solids all disappear. That's all that's left is your sketches. So the one that we're going to be worried about here is we're just going to add on to this line here that's already there, that 60-degree line. So I'll click on it and just kind of continue it. Basically, as long as we're below that disc on the bottom there, then we're good. I'll just over here. Okay. So the next thing that we need is axis for this to revolve around. So I don't actually want to associate it with this sketch here, so I'm just going to click on outside the sketch, but I'll still use the center as a landmark. Click escape because I just want that one line. So I'll highlight it and go to the move tool. So same thing, if you start moving it now, it's going to pivot about the center of the line, but that's not going to work for what we need. So when I click, we'll change that, reorient to the center there. And then you just want to turn it so it's perpendicular. And then drag it below so it's more accessible with the solid in place. Okay, and then you can bring back your solids. So now we come up here, we grab the revolve tool. And the first thing it's going to ask for is a profile. So just click on that one there. Give it an axis. And then it's going to say how many degrees of rotation you want. 360. So you want to leave it in the subtract function. Okay. And just so I can better illustrate that, we'll say hide sketches. And so now you can see that you've got like a nice start to your threads. And you can kind of make it however you want it to be. You can make it, you know, maybe more of a sharp taper in here or however you want to do it. But either way, this is going to make your threads start a whole lot nicer. So that's pretty much it. I hope this has been helpful. I know I had a really tough time finding a good thread building tutorial when I first got into doing 3D design and 123D. So I really hope this helps out, and I'm planning on making more videos, so definitely subscribe.